All right, so this is the notes for exponential decay. The essential question is, how do you find the asymptote of an exponential decay function just by looking at the equation? Exponential decay function is our main idea, so make sure that you copy that down. So with this one, the parent function for exponential decay is the same equation we had for exponential growth, only the b has to be between 0 and 1, but it can't be 0 and it can't be 1, but it can be between. So it's a fraction or a decimal. Whereas when we did growth, the b value was greater than 1. But with decay, the base is between 0 and 1. So then the graph, notice it's falling from left to right, which makes sense, decreasing decay. And it goes through that 0, 1, and it goes through 1b. It also has an asymptote, which the parent function asymptote is y equals 0. Our domain is always all real numbers for both exponential growth and exponential decay, so any of our exponential functions. And then our range matches, so it's y, the 0, and we're greater than because we're using all of them above, all the y values above the asymptote. Okay. All right, so let's do some of these. So then graph each function, state the domain and range, state the asymptote of the graph. So remember, just like exponential growth, exponential decay has the asymptote of that k value at the end. Since there's no k value here, that means that the asymptote is y equals 0, just like the parent function. Okay? So that's where we get that. Domain is all real numbers, and we know this is going to match. This will be the y, this will be the 0. We just figure out the sign. So then I graph y equals 0, the asymptote, with the dashed line. Now let's do a table. Or you can type this in your calculator and it will give you some numbers, but I'm going to plug in some easy ones. So I'll plug in 0, that's easy, and I'll plug in 1. So if I plug in 0, anything to the 0 power is 1. So when I do 1/4 to the 0 power, that's going to equal 1. Then if I do 1/4 to the first power, that's going to give me 1/4 or 0.25. Okay, so then I graph 0, 1, and 1, and then a 0.25, so right about there. And then the shape for decay is that it goes this way. Remember, it cannot cross or touch your asymptote. Okay, so again, 6 points. You got your asymptote here is 1 point. The shape is another point, and having 2 points graphed correctly is your third point for the graph. Here you have domain, range, and asymptote, so the only thing I have left is y is still greater than 0 here because I'm using all the y values above the asymptote. Okay? All right, so you pause it and try example 1b. Then turn it back on to check. Okay, so our asymptote here is still y equals 0 because there's no k value at the end, so it'd be like your plus 0. Our domain is all real numbers, and I know this will match y and 0. Dashed line here at y equals 0. And then I can pick some numbers. So if you plug this into your calculator, I'll use some easy ones again. I'll do 0 and 1. So this one's -3, 2/5 to the 0 power. Well, anything to the 0 power is 1 times -3 is -3. Here I'll do -3 times 2/5 to the first power. So that'll be -3 times 2/5. So I'll make -3 a fraction, 2/5, so that'd be -6/5, which is, if you type that in your calculator, -1.2. Okay, so graph 0, -3, and -1, or I'm sorry, 1, -1.2 is about right there. Now, the reason why this one is flipped from the parent function is because we have that negative in front. So remember that negative value in front, we'll flip it here. So then that means this will be y is less than 0 because we're using all the y's below the asymptote. Remember, it's never equal to, so it's not less than or equal to or greater than or equal to because it never touches the asymptote. Okay. So again, this is the same from the previous day of exponential growth. Translations are the same. The A, if it's bigger than 1, makes it steeper. If A is less than 1, then it makes it wider. And also remember, if A is negative, meaning A is less than 0, then it flips the graph on the x-axis, which is what that last one did. We had a negative value for A, so it flipped it on the x-axis, and it was 3, so that means it made it steeper. Then remember the H, it's opposite, goes right or left, so minus H is actually going to the right, plus H would actually go to the left, and then K, if it's plus K, it goes up, minus K, it goes down. Your asymptote is still y equals whatever that K value is. That's how you tell from the equation. Okay, so on this one, I'm going to start with my asymptote. It's this K value, so y equals -2. I know the range is going to match the y and the -2. Domain is all real numbers. Okay, so then if I had to compare, which this doesn't actually say you have to, but I'm going to just practice, the 3 makes it steeper. That A value 3 in front makes it steeper. Plus 1 in the exponent actually means you go left 1. And -2 is down 2. Okay, so then I know y equals -2. Put in that asymptote on your graph because that's worth a point. Now let's get some values here. So I'll pick, let's see, I'm going to pick -1 because -1 plus 1 will make it 0. And then I'll pick 0 because 0 plus 1 is 1. Okay, so if I pick -1, 1/2, -1 plus 1 minus 2, so that'll be to the 0 power, which 1/2 to the 0 power is 1, times 3 is 3, minus 2 is 1. Then plug in 0, 0 plus 1 minus 2, so that'll be 1/2. Then 3 times 1/2 will be 3/2 minus 2, and 3/2 is 1.5 minus 2. So then that would be minus 2 takes you to -1/2. -5. Okay, so -1, 1, 0, -1/2. And then the shape is falling, so it's decreasing because it's decay. So there you go, and where y is greater than -2 because we're using all the y values above the asymptote. Okay, and that's it. All right, so example 3, describe the translation of the graph compared to its parent function. So tell me what it's doing, right, left, up, down, wider, steeper. That's what that means. And then state the asymptote of the graph. So go ahead and pause it and try those, and then unpause it when you're ready to check. All right, so part A, you should have x plus 2 means we shift left 2. It's opposite of what it looks like. And the plus 6 at the end means we go up 6. And then your asymptote is y equals 6. Now remember, for the asymptote, you can't just write the number 6. If you do that, you'll lose half a point. You have to write the equation y equals 6. And then for part B, there's no a value, so we're good there. There's no h value up with the exponent, so this one just shifts down. And then your asymptote should be y, or yeah, down 2 should be y equals -2 to keep the sign. Again, if you just write -2, you'll lose half a point for not having the y equals. All right, so you need to copy the examples over on the left-hand side, and then all you're doing here is stating the asymptote, so you don't have to do anything else, but just tell me the asymptote. So pause it, copy, and then write the answers in the right-hand column, and then unpause it to check your answers. Okay, so part A is minus 2 at the end, so then y equals negative 2 is your asymptote. For part B, 3 is your k value at the end, so then your asymptote is y equals 3. Good. So don't forget to do your repetitions in your notes. Then you can work on the worksheet.